90 minutes to glory. That's literally what it all comes down to, right? You've spent months studying, and now you have just one short window to prove exactly what you know. Welcome to your ultimate game plan for the Cambridge AS and A-Level Computer Science Syllabus 9618. Today, we're not just reviewing basic concepts you already know. We are diving into a highly specific, notoriously difficult, high-stakes topic: mastering sequence constructs in pseudocode. If you've been doing past papers, you already know the pressure is on when you see these questions pop up. They're massive, they're intimidating, and they carry a ton of marks. But today, we're going to completely demystify them. We're going to look at exactly what the examiners are actually searching for in your answers. By the end of this, you are going to have the insider's blueprint to step into that exam hall and absolutely secure those top-tier marks.
Okay, let's dive into this. What you're seeing right now isn't just a casual observation, it is a direct, urgent warning straight from a Cambridge senior examiner. They explicitly report that sequence constructs in pseudocode consistently trip up even the absolute best, most prepared candidates year after year. It is one of the most misunderstood areas in the entire field of computer science for this syllabus. You might be wondering, why is that? It's because candidates fundamentally treat it as a pure memorization exercise. They try to cram code snippets rather than treating it as an applied, highly logical framework. The stakes here are incredibly high. A poorly structured sequence can completely tank your grade, but once you understand the actual rules of the game the examiners are playing, it changes everything.
To get you to that championship-level execution, we've broken down this explainer into 5 key parts. We'll start with the sequence construct challenge, look at the core theoretical foundations, map out your step-by-step methodology, show you how to evaluate algorithm quality, and finish with the top 3 examiner warnings.
Let's kick things off with Section 1, the Sequence Construct Challenge, and why shifting your perspective is absolutely critical.
The absolute biggest hurdle you're going to face isn't a lack of programming knowledge. Honestly, your syntax is probably fine. The hurdle is a fundamental misunderstanding of what the exam is actually assessing. This brings us to your absolute secret weapon for the 9618 syllabus, the method mark strategy. Look at this definition: the examination principle where marks are awarded for demonstrating the procedural process, not just the final coded solution. Examiners are essentially looking under the hood at how your brain works. If your final code has a missing semicolon or a minor logic hiccup, but you have clearly documented your logical sequence, your step-by-step deduction, and your problem-solving process, you are going to pick up a ton of crucial method marks. You are being graded on your algorithmic thinking, not just your ability to act like a human compiler. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so remember, capturing these method marks is how you guarantee a baseline of points, even on the hardest, most complex pseudocode questions.
Moving right along to Section 2, Core Theoretical Foundations. Let's look at what Cambridge is actually testing when they hand you that paper. To really leverage that method mark strategy we just talked about, you have to understand the specific assessment objectives the examiner is holding in their hand while grading your paper. They target 3 distinct cognitive domains. First up, knowledge and understanding of fundamental principles. That's your baseline. Second, and this is highly critical, the application of those principles to unfamiliar, extremely specific contexts. They are going to throw a scenario at you that you've never seen before. And third, deep critical analysis. The syllabus specifically emphasizes that top-performing students exhibit a connected conceptual understanding. It is never, ever just about knowing a solitary fact. It is about how you connect that fact to a brand new, complex problem on the fly.
Let's make this concrete by looking at 2 hypothetical students. Notice the stark contrast the examiners highlight here: analytical depth versus superficial breadth. Let's say we have a student named Alex. Alex overloads his answers with raw computer science facts, basically just doing a massive, generic code dump, hoping something sticks, but there's zero real analysis. That is superficial breadth. Then we have Sam. Sam panics, rushes through the paper, and completely misses the specific command word requirements, resulting in a super vague answer. Neither of them gets the marks. Contrast their approaches with analytical depth. This is where you pause, deconstruct the command word, and build a sequence construct tailored exactly to the prompt. The assessment framework explicitly prioritizes that analytical depth every single time, over just vomiting facts onto the page.
Which leads us perfectly into Section 3, the algorithmic step-by-step methodology. This is your framework for success.
Since we know examiners desperately want to see deep, structured reasoning, you have to have a reliable system to generate it under intense time pressure. You can't just wing it. This is the exact 4-step practical methodology top-scoring candidates use to move from a confusing abstract problem to a perfect pseudocode solution. Step 1.
decomposition. You have to break the massive problem down into logical, bite-sized chunks. Step 2. Data structure selection. You need to explicitly prove why an array, a record, or linked list is the exact right tool for this specific job. Step 3. Efficient implementation. This is where you actually write the sequence construct. And Step 4. Rigorous testing. Algorithmic thinking requires you to follow these steps sequentially. If you make this 4-step process visible on your paper, the examiner literally has no choice but to award you those juicy method marks.
Now, this structural framework also naturally extends into data processing, which is a massive part of sequence constructs. Let's do a quick mental challenge. Imagine a complex data chart or an array of binary representations sitting on your exam paper right now. You have 60 seconds to process it. What do? Your methodology needs to be razor sharp. First, you extract the relevant data from the binary representations or the dataset they've given you. Don't look at everything, just the core trend. Second, you perform the required calculations systematically, show every single step. And third, you draw evidence-based conclusions from that math. If you can integrate this data interpretation seamlessly into your pseudocode, you are proving incredible analytical depth.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's tie that methodology together into what we call the exam execution standard. When you turn the page and see a terrifying 15-mark sequence construct question, this must be your automatic flow. Deconstruct the question. First, what is the command word asking? Extract the relevant data. Select your analytical framework. Execute your logic with totally clear, unmistakable pseudocode notation, and finally, present it using the exact correct technical terminology from the Cambridge syllabus. If you follow this standard sequence, you're building a bulletproof answer.
That brings us to Section 4, Evaluating Algorithm Quality. This is where we get into the critical analysis that separates the A grades from the A stars.
Generating the pseudocode is honestly only part of the battle. Top marks in the extended response sections are reserved for candidates who can take a step back and brutally evaluate the sequence constructs they've just built. Examiners want to see evaluative thinking, but what does that actually look like on paper? It means you don't just present a solution and walk away. You briefly consider multiple solutions. You analyze the structural trade-offs, like why did you choose a while loop instead of a for loop here? You acknowledge the limitations of your own system, and most importantly, you justify all your decisions with hard evidence. You need to make a clear point, provide evidence from the scenario, explain your technical reasoning, and link it right back to the prompt. Showing the examiner that you know exactly why your sequence is the best option is the ultimate flex.
To actually justify those decisions convincingly, you must evaluate your algorithms against specific quality metrics. Top candidates always talk about time complexity, meaning how fast is this code going to run as the dataset grows, and space complexity, how much memory is this construct hogging. Finally, you absolutely must talk about edge cases. If you can concisely explain how your sequence construct handles extreme, weird data inputs or boundary constraints without crashing, you are demonstrating total, undeniable mastery to the examiner. Finally, let's look at Section 5, Top 3 Examiner Warnings. This is all about avoiding the traps that catch out 80% of students.
We have dug deep through the Cambridge Principal Examiner reports to find the exact places where students are bleeding marks, and we've ranked them, counting down the absolute worst mistakes you can make. Number 3 is vagueness. Remember our hypothetical student Sam? Sam rushes and writes answers that lack specific technical details. Examiners hate that. Number 2 is boundary ignorance. Students consistently forget to test their boundary conditions, the absolute highest and lowest possible values, and their loops break. But the number 1, absolute most catastrophic mistake you can make, context disconnect. This is when you provide an answer that is completely detached from the specific real-world scenario they gave you in the prompt.
Let me show you exactly what I mean. Look at the generic code dump on the left. This is what our student Alex did. It might technically be valid pseudocode in a vacuum, but it completely ignores the actual problem. It just uses generic X and Y variables. Now look at the scenario-locked sequence on the right. This is the gold standard. This code uses the highly specific variable names from the prompt, maybe it's checking the temperature of a specific greenhouse engine, and it addresses the unique constraints of that exact system. The generic dump on the left gets minimal method marks, the scenario-locked sequence on the right gets full marks, every time.
So the crucial point is captured right here in this massive examiner alert. Always link every point, every variable, and every logical step back to the given scenario. If the exam question is about a factory's automated conveyor belt, your pseudocode and your evaluation paragraph better reflect factory conveyor speeds and sensor limits, not just textbook definitions of a while loop. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
Let's rapidly summarize the key takeaways from today's explainer. I want you to lock these into your brain right now. First, method marks reward the analytical process, so document your logic clearly. Second, always rely on the 4-step decomposition framework so you don't freeze under pressure. Third, elevate your evaluative answers by talking about time complexity, space complexity, and edge cases. And fourth, your golden rule. Ground absolutely every single answer firmly in the context of the exam scenario. Here's your final reminder: subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCE and click that bell. Don't let another exam pass you by.
I want to leave you with a direct challenge today. Go pull out your absolute last pass paper attempt for 9618 and be brutally honest with yourself. Did you explicitly check your boundary conditions, and did you truly lock your sequence construct into the exact scenario context, or did you write a generic code dump? Identifying that specific gap in your own work is your first real step toward exam mastery. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep practicing, keep analyzing, and we will see you next time.